Hello guys, welcome to the class today. I'm Nilakanta Bhanu Prakash and I'm the fastest human calculator in the world. And today we will be exploring a little bit more into the chapter which we have started, the chapter of real numbers. But we'll be starting in a few minutes. But in the previous class we have done a little bit of introduction. हमने थोड़ा बहुत इंट्रोडक्शन किया है, थोड़ा बहुत इंट्रोडक्शन में हमने शुरू किया है कि हम ये क्या बोल रहे हैं, क्या स्टडी कर रहे हैं, why are we doing this in the first place. And just so you guys know, quick introduction about myself. I am Nilakanta Bhanu Prakash, the fastest human calculator in the world. What that means is that I hold a few world records in such a way that I calculate quicker than the speed of a calculator. We can be showcasing that in the next classes. But in this class, we will be discussing one of the most important chapters of class 10. Class 10 में one of the most important chapters जो real numbers है, which is the foundation for the entire higher mathematics to come. Because बाद में इसमें the terms, the methods, and a lot of these things which we learn are some things which we will be studying across in the 11th class and 12th class JEE bhi hai, where we extend our understandings of what this is. So hope you're doing fine, and in this lockdown period it's wonderful that TikTok has brought to you guys this wonderful campaign of studying at home study, and I'm more than happy to contribute in my own way. So as we know, since you're all here, couple of quick advices which I have for you guys. आप दोनों दो तीन advices जो मैं देना चाह रहा हूँ आपको before the class starts. The class is going to be starting at 11 sharp. So couple of quick advices which I have for you guys is to use this lockdown period to your highest advantage, and be strong with your basics in mathematics. Like real numbers, as I mentioned, forms the foundation. In a similar way, I will be hand holding your education and study for the next 1 month or so, until whenever the lockdown extends. And मैं आपको ये बोलना चाह रहा हूँ कि आप ये वीडियो देखते हुए आप जो भी कमेंट कर रहे हो, हम नेक्स्ट क्लास में वी कैन एड्रेस देम, एंड आई विल आल्सो बी गिविंग यू. सो हाउ विल द क्लास स्ट्रक्चर बी इज दैट मैं आपको थोड़ा इंट्रोड्यूस करूंगा कि ये चैप्टर में अभी नेक्स्ट ये क्या है. सो अ क्विक इंट्रोडक्शन इज दैट रियल नंबर्स जो हम लेसन कर रहे हैं ये पूरा 6 to 7 सेशंस में स्प्लिट हुआ है. हमने एक ऑलरेडी सेशन किया है, पर वो इंट्रोडक्टरी सेशन था. आज से सेशंस जो है वो इम्पॉर्टेंट हैं, एंड ये पूरा आफ्टर 7 days are done, you will sort of understand the entirety of what this entire lesson is. So we'll build purpose first, because mathematicians में हम mathematics में हमको excel करने के लिए हमको fundamentally 3 चीज़ें पता होनी चाहिए कि ये कैसे हो रहा है, ये जो हो रहा है क्यों हो रहा है. The other thing is इसको क्यों इन्वेंट किया है, इसको क्यों डिस्कवर किया है. Is that why did someone in the past come up with something, उनका challenges क्या थे, एंड उसका necessity क्या था. Because मैंने जो बोला है आपको कि लास्ट क्लास में कि that all of these building of the entire sets जो हम बोलते हैं number systems, real numbers जो है एक number system है, is happened because of need. People started off with counting numbers as tally numbers and natural numbers, as we've talked about in the past, because they needed some way in which they could keep a track of the number of possessions they have and things of these sorts. Fractions came into existence because of the fact that there were people who wanted to represent parts of a whole. So I mean, एक पूरा चीज़ में से उनको आधा को represent करने के लिए या 1/3 को represent करने के लिए a certain part of a whole is a 1, and a certain part, so to indicate numbers between two natural numbers, जो 1 नहीं है 2 नहीं है, मेरे पास 1 से ज़्यादा है 2 से कम है, इसको represent करने के लिए people discovered what fractions are, and said that the numerator means the number of parts, denominator means the number of parts out of. So p divided by q, ये जो चीज हुई है, p divided by q means that if there are p parts out of q parts, it is denoted as p by q. 1 by 2 means if there are two parts in a whole, अगर हमको पूरा whole एक 1 को हमने 2 समझा है, then the one part out of these two parts, it's like basically having a half. So ये fractions को discover किया. Later people saw that there was a possessional need and understood that negative possession is also possible if you owe someone money, if एक debt, इसको denote करने के लिए people discovered what negative numbers are, which was later called on to be, what do we say, integers. So the collection of positive numbers, negative numbers along with 0 was called integers. And then we looked at rational number, which included negative fractions also. So any number which is of the form p by q, which p by q is also called a ratio. Ratio is denoted the same way, p divided by q, p is to q. And the numbers which can be denoted in the form of p by q, where q is not equal to 0, because q 0 nahi honi chahiye, because if q, and let me write it down for you guys here. So any number which can be written in the form of p divided by q, where ये q है, ये not equal to 0. Why should this not be 0? q should not be 0, because अगर q 0 हुआ है, then we have an issue, because we can't understand and denote what a part of a whole is when the whole itself is 0. So p divided by q, ये जो चीज़ है, इसको हम accept नहीं करते हैं as a rational number. So this is something which we sort of understand as a preliminary set. So ये हमने already discuss किया है, and we will be looking a little deeper into what our understanding about what rationals are, what irrationals are, and things like these. And today's class, as I mentioned, is about visualizing these numbers, and also diving a little deeper into what do we say, into how we can be using these numbers and rationals and irrationals. How did these come into existence, and ये existence में आए कैसे हैं? So let's begin, because we are on time, and let me give you a heads up and start. So as we have discussed yesterday, we said that the origin of numbers happened from tally marks. A quick recap, I'm going to run through this in the next 3 minutes. Tally marks, and people eventually saw Roman numerals. The problem with tally marks and Roman numerals क्या था कि number 0 नहीं था उसमें, so we had to remember multiple what do we say, symbols to denote it, because L is 100, otherwise we had to recursively use the same. The discovery of one invented something called the placeholder system, which is the Indo-Arabic system. 0 to 9, 9 के बाद 1 and 0 unit place और tens place को denote किया गया है, and 121 is written as 100 into 1 plus 10 into 2 plus 1 into 1. And quick denotion and exercise which I have given you yesterday is to figure out what the binary 2 system is, and let's look at binary system, because I think I wanted to give you that understanding, because there are multiple other ways of understanding. So a binary system is where there are only two numbers, 0 and 1. There are only two numbers. Let me zoom this for you. Yeah, let me zoom this for you right here. So there are only two numbers in the binary system, and the binary system has the numbers 0, 0 and the number 1. There are only two numbers in the binary system, and after 1, the next number which is there is, after 1, the next number, which is 2, is denoted by 1 and 0. So the units place is this, the tens place is the twos place in this. So ये जो है इसको twos place बोलते हैं, this is the twos place. So if you want to understand a number, let's say if there is a number 101 in binary, what does 101 mean? 101 is, as we mentioned, 1 into 0, just like how we have done the tens place system here, plus 1 into 1, this is 1 here, this is 1 right here. Let me make sure कि आप confuse नहीं होगे कि ये 5 है, because 5 हमारा denotation भी यही है 5. So let's continue. Yeah, 1 into 1, ones place, plus ये जो 0 है, 0 is in what place is this? अगर ये हमारा 10 सिस्टम में होता था, so this into 10 होता था अभी, बट हमारा क्या है, this into 2, because हमारा सिस्टम बाइनरी है, and this into 2 square, ये 100 जो है इधर is 10 square, right? In the similar way, this is going to be 1 into 2 square, which is 4. So in real life, in the 10 system, what is 101 going to be? 101 in binary is going to be 1 plus 0 plus 4. So this is the denotation of 5. So अगर आपको समझ में आया है तो ठीक है. So the idea is to, let me get it back into the bigger size for you, and so the idea is that there is 101 में हम denote कर रहे हैं इसको 1 into 1, 0 into 2 and 1 into 2 square. So if you understand this, that's great. If you don't, we can, it's just a question which we had yesterday. We don't really have to understand that for the rest of the lesson. So let's go ahead. Yeah, I think I'll place that back. Yeah, looks great. Looks great. Yeah. So the immediate next question was, we were talking about what natural numbers were. We said natural numbers were counting numbers, as we mentioned. We looked at what whole numbers were. We said whole numbers are natural numbers with 0. We said integers are natural numbers at 0 along with the negative numbers. Then we looked at fractions, where we said that fractions are the numbers which can be written in the form p by q, where q is not equal to 0 and p and q are positive. So we said that these are parts of a whole. So a 1 by 2 is denoted this way. If 1 is a full circle, then we have this as our 1 by 2. So we have done this, and we have gone into what rational numbers are. Rational numbers, as we have said, are numbers which can be written in the form of a ratio. This is a rational number, p is to q, where p is to q is also equal to p by q, where q is not equal to 0, q is not equal to 0, and p and q, both of these are integers. We've talked about it. So we said p and q are integers. So this was what our take on rational numbers was. So let's look at it. So we were discussing what a number line is. So let's go and discuss this a little deeper, because this forms one of the most fundamental understanding towards why there is a need. So an imaginary line on which all the numbers are placed is called a number line. So let's look at it. हमने ये किया है पहले क्लासेस में, is that if this is 0, this is 1, this is 2, and this is 3, and so on and so on. This is -1, this is the -2, and so on to the other side. So this extends infinitely, this extends infinitely. ये infinitely लंबा line है जो हमारे पास है number line. So this goes in both directions infinitely. So what we said is that a number line represents the set of all the numbers which we want. सो अभी हमको 0 और 1 के बीच में एग्जैक्टली ये जो है ये नंबर क्या है. इफ वी वांटेड टू नो व्हाट दिस नंबर इज, हमारा आंसर क्या है. इफ 1 और 0 का बीच में जो है नंबर ये 1/2 है. इन अ सिमिलर फैशन दिस इज -1/2. So if you see, we were sort of, when we looked at fractions or when we looked at rational numbers, we were trying to look at all the numbers which are there on the number line. So हमको basically number line के ऊपर जो भी numbers है उनको देखना था, and we wanted to get it. So are there any numbers, as you think, any numbers which are on the number line, somewhere, but they are not rational. They are not rational. So that's when we looked into what irrational numbers are. Irrational numbers are the numbers which are on the number line. हम numbers के बारे में जो बोल रहे हैं, all the numbers on the number line are called real numbers. So real because they're real, they're on the number line. So numbers which are on the number line but cannot be expressed in the form p by q, जो p by q form में express नहीं कर सकते हैं, these numbers are called irrational numbers. And we said that the rational numbers and the irrational numbers together constitute the real number space. So जब हमारा number line हम ले रहे हैं तो इसके ऊपर हमारा rationals और irrationals दोनों present है. And हम ये क्लास में हम देखेंगे कि ये rationals और irrationals को हम visualize कैसे करें, और irrational numbers के 2-3 example very quickly we'll look into it. So let's look at a couple of really good things to understand in this. So a decimal is a number which is separated by a dot and extends on both sides. So an example would be 23.4. Let's say 7185. 23.7185. आपको पता है कि पॉइंट के बाद जो आता है वो 1 से कम होता है. एंड just like how this is the units place, how this is the tens place, this is the 1/10ths place, and this is 1/100ths place, and so on and so forth. This is something which we already know of. So हमको ये पता है 1/100, 1/1000 and so on. So as we know, we would like to broadly categorize the numbers and the decimals which we know of in a few ways. We basically categorize decimals into 2 types. The 2 types are terminating, non-terminating. So what does terminating mean? Look at my point right here. Terminating decimals are decimals which end. Terminating, what does the word terminating mean? Terminating जो खत्म हो जाता है. तो हम terminating बोले तो 1.2, 2.56, 1.6788, ये जो end हो जाते हैं 1.788, ये end हो जाता है, इसके बाद कुछ नहीं है. After this, if 1.2 के बाद what is the decimal? 0, 0, 0, 0. तो हम जब डेसिमल को स्पेसिफाई नहीं करते हैं ये 0, 0, 0, 0, 0 करके हो जाता है. सो टर्मिनेटिंग डेसिमल्स आर ऑलवेज रैशनल. व्हाई आर टर्मिनेटिंग डेसिमल्स ऑलवेज रैशनल? बिकॉज व्हेन दे आर टर्मिनेटिंग, लाइक 1.2 इज टर्मिनेटिंग, वी कैन जस्ट राइट देम डाउन एज 12 डिवाइडेड बाय 10. आप न्यूमरेटर को और डिनोमिनेटर को 10 से मल्टीप्लाई करो, सो वे हो जाएगा 1.6788 जो है इसको हम लिख सकते हैं 16788 डिवाइडेड बाय 1/1, 2, 3, 4, 5 divided by 10,000. ये जो है number, this is how 1.6788 is represented. So we could represent 1.6788 in terms of a decimal which is non-repeating. So let's take a quick understanding of this. So what do we know? We know that terminating decimals are always, as we know, rational. So what is the second type? These are all, as we mentioned, let me write it down, rational. So rational numbers are, let me write it down here for you, rational numbers are denoted with the number, the letter Q. So this is a rational number, and let me denote it with the same thing so that I would make you guys used to the notation, which is quite important in this case because we'll be using it subsequently in a lot of different places. So let me look at this. So this is a part of Q. Terminating decimals are this. Non-terminating decimals are again of two types. Non-terminating recurring, non-terminating non-recurring. Now let's look at what recurring and non-recurring are. So the word itself says, right, recurring bole to repetition. As I mentioned, non-terminating decimals are of two types. ये non-terminating recurring. Let's look at this first. What is recurring? Recurring is repetition. So let's say 1.555 and so on, and it's only 5 which is being repeated infinitely many times. Is this terminating? No. But this is non-terminating, recurring. So this comes into this type. So how can this be converted into a P by Q form? Because हमको basically देख रहे हैं कि ये rational है या irrational, right? So usually आपको ये method है कि इसको आप x लो, then if you take this as x, what is 10 multiplied by x going to be? 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x is going to be 1, 5, yes, you have guessed it right, point. 10x और x ये पूरा आप subtract करोगे, let's say आप ये subtract करोगे तो आपको ये पूरा ये जो है ये कैंसिल हो जाएगा, एंड ये आपको 15 minus 1, 9x is equal to 14, आपको रह जाएगा 9x is equal to 15.55555 minus 1.55555, 5.5555 पूरा जो है वो कैंसिल हो जाएगा, एंड आपको इसमें रहेगा 14. So by the law of transposition we would know, एंड आपको इसमें रहेगा 14. So by the law of transposition we would know, एंड आपको इसमें रहेगा 14. So by the law of transposition we would know is not equal to 0, p and q are integers. So we can say that every non-terminating recurring, and when I say recurring can be in any format guys, so that you want आपको अच्छे से समझ में आने के लिए मैं बोल रहा हूँ कि ये 1.753 753 ये जो है, this is also a non-terminating recurring decimal because 753 इज बीइंग रिपीटेड, हम इसको x मानेंगे और हम इसके बाद 1000x कैलकुलेट करेंगे which will be 1753 point so and so subtract करके हम ये p by q फॉर्म में represent करेंगे. And you've done this in the past lectures, so if you have any doubts on this I can clarify to you later, but that is what we say. Now let's rub this all out, because we have come to the most important part of this entire decimal categorization, which is non-terminating, non-recurring decimals. So ये टर्मिनेट नहीं होता है और ये पैटर्न भी नहीं होता है जहां ये टर्मिनेट होता है, रिकर नहीं होता है. देयर माइट बी अ पैटर्न but they might not repeat. So let's look at this. 1.23 2 2 3 1 2 3 1 1 2 3 1 1 1 and so on. ये एक एग्जाम्पल है. मैं और एक लिखूंगा इधर 7.50 7.6 समझो 6 0 6 0 0 6 0 0 0 and so on. Let's look at these two numbers. These are infinitely extending, so these are non-terminating. This is non-terminating and this is not recurring because 2 3 को हम बार लगाएं, 2 3 1 को अगर हम बार लगाएंगे then this 1 ये कहाँ से आया है, we don't know. So 2 3 को हम बार नहीं लगा सकते हैं. So here this is a typical example of a non-terminating, non-repeating decimal जो हमारे पास है. So ये non-terminating, non-repeating decimal. Let's say look at the next question. 600 6000. The number of zeros are increasing, so there is no pattern in which this entire thing flows. So ये number है, ये दोनों non-repeating भी है. Yes, they are non-repeating too. So hence they are non-terminating, non-repeating, and most importantly of all our understanding, cannot be written in the form of p by q. Cannot be written in the form of p by q. Absolutely not. So when there is a non-terminating, non-recurring decimal, it is always irrational. Let me write it down for you. It's an irrational. A few examples of these are e pi square root 2. These are also, and non-terminating, non-recurring decimals are also called as transcendental numbers. Transcendental numbers are numbers which don't have definitions infinitely, and they follow nothing. So as we know, the conditions for irrationality, we have discussed them in two definitions. One is the fractions definition, one is the decimal definition. In the fractional definition, this is the let me come back to you. The fractional decision says that you cannot be expressing the number in a p by q form. तो मैं ये fractional definition हो गया, and the decimal definition says that it's a non-terminating, non-recurring decimal, which we know of, which is the condition for irrationality. Now let's look at this broadly. Let me zoom this up for you so that you get a good view of this. Hoping, yeah, I hope you are getting. I'll push myself up here. Yeah. So as we know, rational numbers are the numbers which can be expressed in the form p by q. Examples are 4 by 1, 220. So integers are the numbers like this, which are positive, negative. Terminating decimals are decimals like these, which are terminating, right? I told you that they end. Recurring decimals are decimals like these, which repeat. Integers are here. Putting recurring decimals, terminating decimals and integers together, this entire big box which we have, ये जो हमारा big box जो है, rationals, irrational, so integers, terminating decimals and recurring decimals are all rational numbers. So let's not look into this name, but the things which cannot be expressed in the form of p by q are things like the square roots of 2, square roots of 3, square roots and things of these sorts. And transcendental numbers, they have no pattern and repetition. One of the most important numbers which we know of hence is called pi, and there is another number called the natural logarithm number e. So pi and e are two numbers which are transcendental, so these are examples of the same. Let me make it back to its size again. Let me get back, yeah, absolutely. So a few examples for this, as I have mentioned here, are that whole numbers, integers are bigger than whole numbers, the rationals are bigger than the integers, and then there is irrational numbers, and the set of all of these together right here is the set of real numbers. Absolutely. Now let's come to the visualization of what the concept of an irrational number is and how people have come into existence. So as you know, the Pythagoras theorem, Pythagoras says that the side square plus the side square is the hypotenuse square. I'm sure a lot of you already know this. Side square plus another side square, side 1 and side 2 is the hypotenuse square. Now let me show how the number root 2 was hypotenuse square. Now let me show how the number root 2 was hypotenuse square. Now let me show how the number root 2 was hypotenuse square. Now let me show how the number root 2 was hypotenuse square. Now let me show how the number root 2 was, and then he joined, see, he drew these at right angles and then he joined these. So when he joined these and measured it, he understood that the measurement which was done was a number which was non-terminating, non-recurring. So such a number came into existence because Pythagoras found so, and this is how irrational numbers came into being. The other quick example of how irrational numbers came into being are that when people were first discussing and understanding how circles and diameters work, people looked at the circumference of a circle, divided that by the diameter of the circle. Let's say the diameter here is d, and they've measured the circumference by a string. They have found this ratio which is there to be this ratio of a circle where circumference divided by d, let me get it here for you because it's out of the screen, this to be the number pi, which is also non-terminating, non-recurring decimal. So this is how the first things were understood, and that is how we arrive at our set of real numbers. ये जो हमारे ऊपर आगे सामने है. So we've come to the end of the chapter, but this is exactly where I wanted to leave you guys at. I would want you to do the following. There are a couple of things which I want you to do. Why? As I said, I told you that the square root of 2 is irrational, right? And let's look at why. That's going to be our next class. Why is square root 2 irrational? Because मैंने बोला है आपको that this was measured by Pythagoras and said that this is a non-terminating, non-recurring decimal. But is there a better way in which we can prove this? For which we will be needing a couple of more theorems. So our exercise in the next few classes would be to understand and prove that root 2 is irrational. And most importantly, the other thing which we have is the concept of Euclid's division lemma. So why is Euclid's division lemma important? You tell me, look at it by the next class. So right now you're ready and good to go to understanding what irrationals and rationals are. We wanted you to do some quick research on this. that should be pretty much about what I have to say today. So thanks a lot for joining in. I am Neelakanta Bhanuprakash and I am the fastest human calculator in the world. Should be pretty much about what I have to say today. So thanks a lot for joining in. I am Neelakanta Bhanuprakash and I am the fastest human calculator in the world. Should be pretty much about what I have to say today. So thanks a lot for joining in. I am Neelakanta Bhanuprakash and I am the fastest human calculator in the world. Now you know what rationals are, irrationals are, and now you know why people came into understanding what rationals and irrationals are. That's because someone right there found a triangle. किसी को triangle मिला है, circle मिला है, divide करेंगे तो उसके पास मिला है non-terminating, non-recurring decimal, which forms the basis of what we are going to be studying in the days to come. All right then, see you. Have a nice day and meet you tomorrow.